So now we're going to look at more advanced uses of JDBC, including how to look at the metadata for the database and the metadata for the result set, and also how to look at callable statements, etc. So the other thing that you might want to do is also package your code slightly better. What we were looking up until now is putting all of our Java code in one single program without any kind of like packaging of the code in any adequate way. If you are good with your Java, you might want to do better than that. You might want to package certain things into methods in Java that you can then call. So, for example, we can have a database object defined. So we can have something like this code where we have defined JDBC sample 5 as a class, and then within that we are going to connect to the database. So we have a object called database 5 on which we call the connect method, and then within that we have our result set, rs, and what we're going to do is, because database 5 now is an object, we're going to call a method that we define. In this case, the method gets all of the employee details. So we're doing exactly the same as we were doing before, but we're just packaging the code in a slightly better way, instead of having what they call a spaghetti code, all of it in one program. So then within that, it works better if you don't speak what I do. Otherwise, I have to shout even more than I do, which is bad for me, because I intend to party tonight, and I don't want to get there and be already tired. Thursday is my party night. I go out on Thursdays, and I stay until late. So on Friday, I'm really dead, because I've done 4 hours of lectures, and then I go out partying, so respect. Otherwise, my partying later will be spoiled. So we have another method here, update hourly rate, which we pass parameters to. In this case, the first parameter is the employee that we're going to update. The second parameter might represent the hourly rate that we want to give them. And then we print out however many records we've updated. And then we call the disconnect method that we have defined somewhere else on this database object. So I'm doing the same thing. I'm just packaging my Java code in a slightly better way. And then I might have some exception handling. So if I want to do that, I have to define.
Sorry, I missed my stuff. Can you stop talking, please?
You missed most of that slide. You want me to go back over it? So really, all I'm doing here is just using the same code as I did before, but it's a matter of how you present your Java code. So I'm going to now have methods that perform particular actions in the database. And I'm going to associate them with the database object that I declare. So the code that I'm using in Java is the same, but I'm packaging it into methods that I can then call associated with the database class. So this first slide, I have a connect method. I've declared an object which I call database 5. And then I can call the connect method, which I've defined elsewhere in my code, to do all the connection. And then I can also call a method called getAllEmployees on that object, which is going to retrieve all of the data, or I could have a method that updates the hourly rate to which I pass parameters. So what I'm doing there is I'm using exactly the same code as I did, but I'm packaging it in Java in a better way, because I'm creating methods that I can call associated with the database object. So in order to do that, I might have to have I have to define all of these additional methods that I'm going to use. So I have a public class database 5, which allows me to then establish methods of type database 5. And I'm going to have a static connection object called con, which is going to be shared by all the methods. And I'm also going to have a static statement, STMT, which is also going to be shared by all the methods. Might not be the best way of doing it, because if I'm sharing those, it means that I cannot use them in 2 methods at the same time. I have to finish with one result set before I use it again. But it's one particular way of doing it. And then I need to have, for example, a connect method. So this is just going to define the code that I was using before within my program as a connect method. So within that, I am going to declare my driver as I did before, and then I'm going to establish a connection as I did before. What I've done this time is I've packaged it as a method that I can call. So that method is going to establish my connection for me. And then I might have some error exception catching code associated with my method. So if there is an error, the exceptions are caught there, and then I can handle them later. Then I might also have a sample retrieval method, which is going to be the getEmployee getAllEm. So that method is going to be returning a result set, and it will throw SQL exception. And in the beginning, I define my result set to be null. Then I define my string as I did before. I execute my query, and that gives me the result set. I can catch any exceptions that occur, and if there is an exception, then I set rs to null, and I throw a C so I can deal with it in the calling environment, and at the end of that, I return the result set. So that is just doing the same. It's just the way in which I'm presenting my Java code. From the point of view of accessing the database, the statements that I'm performing are the same. I can also have my update hourly rate method, which takes an integer, which is going to be the ID of the employee I want to update, a double, which is the new hourly rate that I want to give it. Again, throws an SQL exception. I start by defining my integer row count to be equal to 0, and then I will execute this piece of code, which puts my update statement into a string, executes it against the database. If there is an error, I will catch the exception, and I will throw that error to the calling environment, and I will return the row count. So that is just really packaging my code into methods. And I might also have a method for disconnecting called disconnect, which throws an SQL exception. Then I have try if the statement is not equal to null, STM close. If connection is not equal to null, connection.close. I catch any exceptions, and I put there my finally code, which is always going to execute no matter what happens as part of the program, to make sure that I always close and release my resources. So if I want to use that, then I need to first connect to the database as I did before. So if I declare this database 5, I can call this method connect, database5.connect, to make the connection to the database. Now, if I then call the static method getAllEmp, that is going to return to the calling environment the result set. I can then handle that result set in the calling environment just as I was doing before. So the calling environment is going to deal with the result set and also close it once it has dealt with it. So I could have something like result set rs equals database5.getAllEmp. So it's the calling environment that is declaring the result set. Then it's going to do whatever it wants with it. It might be display it, the name, to the string, and then you will need to release that. And if I have the update hourly rate method, which takes two parameters, and the return value is going to tell me how many rows were updated by that particular statement, then in the calling environment I'm going to declare an int variable to take that count of rows that were updated and count, and then I will call that method against the database object database5 update hourly rate with a particular ID and a particular hourly rate that I want to update, and then I can print how many rows were updated as a result. All of these programs, by the way, you will have accessible to you when you go to the labs, so you can execute them within NetBeans, see how they work, alter them as you wish, and that will be how you will begin to work with the Java. And once I have done all of these things, I want to call my disconnect method, which is going to perform the tidy up on the database object so that I can release all my resources. So I'm doing the same. I'm just kind of like making my code a little bit better. This sample mode is based on a database gateway pattern, but it could be better than it is. This is one way of doing it, but because we have a result set which is connected, it means that all of the statements that you cannot reuse that until it has been used by one, because they're all sharing this result set. Then you need to finish processing it in one before you can actually reuse it. So you cannot use, in this possible way, in this way of doing it, you cannot use the methods to process two result sets at the same time. The static members mean that only one database connection can be used per execution. So you could think of better Java code, but it's one way of making your code slightly neater than having all of the code in one single program. You package it into methods, and then you call those methods. Now, the next thing that we might want to look at is how to handle errors. Now, when you do your own exercise, you could do minimal error handling, or you could try to do a little bit better than that. If you want to get the very, very, very top marks, you want to try to handle your errors as well as possible. But I wouldn't spend an inordinate amount of time in that until you got everything else working correctly. So we can look at how we handle errors. We have this program errors.java, which is going to report SQL exception information. So this is one of the Java programs that will be available to you. Let's say that we have this program where I, again, declare my database, driver, my connection, and so on, establish my connection. And one of the things that I might want to do is, first of all, deal with errors that might occur when I'm trying to do these initial operations, i.e. trying to declare the driver, trying to establish the connection, what happens to the errors that may occur at that point. So, for example, I can have something like try class for name, data source.get class name, and then I have a catch statement, which is going to handle any errors that occur in the program at that particular point. So if there is an error that occurs, then I can print to the calling environment class not found exception, which is going to be giving the program some information on where the error is occurring. In this case, is in declaring this particular resource. And I can also print out this error has an associated message that I can print out to the calling environment. So I can do print line, so print into the calling environment e.getMessage, that is going to give me the error message that is associated with that particular error, so I can see what that error is. Then I might try to establish my connection. As I did before, I have to give my name, my password, and so on, and I try to create my connection object. Now, if there is an error in there, again, I might wish to handle it. Now, in this particular program, what I'm going to do is I'm going to ask the user to enter the select statement they want to execute. I'm going to read it, and then I'm going to try to execute it. So I'm going to say, okay, enter the select statement. Then I read that, whatever they've entered, and I execute it as a SQL statement. If they enter the correct statement, that will be fine. It will execute against the database. If they don't, there will be errors. So this is going to allow me to look at the errors. So what I have there is, if it goes well, then fine. If there are errors, I need to handle them. So how do I handle the errors? Then I have this catch code here, which is going to print out the following. It's going to print out errors occurred, and then it's going to go, because there might be more than one error, they might be chained. So again, the errors is going to be a connected structure that I can look at the first error, and then the next one, and then the next one. So I do that by saying while SE is not equal to null, so if there is one error, it will go through it once. If there are two, it will go through it two, until there is no more errors, in which case that will finish. So what I'm going to do within that is I'm going to print out the message that is associated with SE as SQL exception, the SQL state, and the SQL code. And these codes are a number which are associated with particular errors in the system. So if you want it to be very sophisticated, you can have a lookup to the error number, and that will give you what the error is. So is it to do with a primary key, entity integrity, referential integrity, etc. Or, if you don't want to be so sophisticated, you could just return the code and not try to interpret it in any way. If you want to be very good at error handling, you'll have to interpret the code and give a more astute message to the user, but I don't expect that. If you just return at least the code, so it shows that you have handled the error and shown what the error is, then that will be good enough. So if we look at how that works in practice, there are 3 examples here of what happens. So in the first one, and I'll do it in the program in a minute, what I have is, instead of from, I have typed form, because I'm typing the SQL statement and allowing the program to read it. So I have typed select star form demo.m. So that is obviously incorrect, and it's going to generate an error when it executes. So what I'm trying to do with this program is to catch that error and display it. So this is going to then go into my error catching code, and it's going to have something that says errors occurred. Then it will give me the error message that is stored by the system, which is SQL exception, error, syntax errors, error on or near form. So that gives me an idea of where the error was. And then it will give me position 10. The SQL state is 426. I can barely read it, even though my eyesight is quite good. I don't know why it's so good. 42 something something. That you can find in PostgreSQL as an error code associated with a particular type of error, if you wanted to, and an SQL state. So you have, and then it tells you that's built successfully. This second one, you have an invalid reference to a database object. So instead of table, I've typed tables. So I have typed a statement that is not going to execute. So what I get is error relation demo.tables does not exist, because I'm trying to access an object that doesn't exist. So again, what I'm doing is printing the message, printing the code, so I can see what the code is. And then the final one, I'm trying to access a record that doesn't exist, because I have said select a star from demo.m where the employee ID is equal to 9999. And there is no such employee ID, so again that is going to generate an error, because I'm trying to access data that doesn't exist. So I'm going to get some message that says, I can't read it, or even there I can't read it, whatever. We will look at it in a minute. And the SQL error. So, if I show you that in the NetBeans, I have something called program.errors.java. So I run that file, and what it's going to do is it's going to ask me to enter an SQL statement. So if I say select everything from emp, now it won't know what emp is, because I haven't set demo.emp, so it's not going to find that. So that is going to generate an error. So what my program does is, my error catching code says errors occur, SQL section, relation emp does not exist, position 15, SQL state 42P01. The SQL code may not return anything in PostgreSQL, but this is trying to return, so the one that matters in PostgreSQL is the SQL state. If I did something else like is it the model name by the? So I have tried to select name where demo.empid is equal to 9999. Now it says column name that does not exist, because it's probably not called name. I can't remember what it's called, but I've accessed the wrong column. So that bit of code is just showing you that you can catch the error, you can display the error message, and you can display the code. And that will be minimum error handling. You could be more sophisticated by translating that, but I don't expect you necessarily to do that, to something a little bit more specific that the user may understand better. So we go back to the program. So we have looked a little bit of how we can handle errors, at least minimalistically, by returning the message and the code. The next thing that we might want to look at is how do we access the metadata. Remember that we said when we looked at the JDBC interface that there is all of these methods that allow you to access the metadata for the database and the metadata for the result set. So the result set has associated metadata with it, and that is going to tell us things about the result set that is being returned, the type of the attributes, the length of the attributes, anything we want to know about the result set will be in this metadata, and we might want to access it through the program. So things that, like, for example, the number of columns that are being returned in the result set, whether null values are allowed for a particular column, what is the name of a particular column, what is the data type of a particular column. I can access all of that information from the result set metadata if I want to. And equally, the database itself has metadata, which we have looked at. We can access it also with JDBC through our Java programs. So we can look at things like what tables are visible by the current user, what user is connected, what are the primary keys, is the connection read-only, what are the foreign keys. Any of those things we can also access through the Java program by looking at the methods that allow us to access the metadata. So how do we do that? Again, here is a bit of code that is going to allow you to access the metadata. So we need to still have a connection object. So we declare our connection. We, with that, create a connection object. Once we have a connection object, we can create the statements. Once we have the statements, we can handle the result sets. So what we want to do in this case is also create something, an object of type database metadata. Because what I want to handle is the database metadata, so I declare an object of that type, which I call dbmd, and I create it using the get metadata method on my connection. So that gives me access to the metadata associated with my connection. And I might then declare an array of strings, one of them for table, one of them for view. And what I'm going to do is I am going to now look at what tables are in my connection. So I then can have something that says result set RS tables. So this is something of type result set. And I am going to use my database object to call the method getTables so I can get information on the tables that are in my metadata. And there are four columns there. The first one is the catalog, which I can pass a null value to because I don't have to specify the catalog. The second one is the schema. In this case, I want to, for example, look at the columns that are for the demo schema only. So I want to look at things like the emp table, the project table, the task table, and so on. The fourth one is the particular table I want to focus on. I want them also, I'm going to pass a null value. And the fourth type is the type. So what I do what I want to see in my calling environment is the table of views that are in the demo schema. So I write a string for that. And then I'm going to process my metadata, which is in this result set object. So I'm going to process it and say, well, there is a next object in that set of results, which is my metadata. Then I am going to create a string variable where I'm going to put the third parameter and another string variable where I'm going to put the fourth parameter, and I'm going to print those out. So if I do that and then I have to close my resources. So if I do that for my I think it's this one. If I run that, what I get to see there is my program has just said the tables of views in demo, which is the schema that I'm looking at, and then it's going to cycle through all of the results that I get and show me what tables I have. And I have dependent, which is of type table, because first I did the name, then the type. I have project, which is of type table. I have task, which is of type table. SYZ, which is of type table, and project hours, which is view. So all that is done is it's gone through the metadata and it's giving me for the schema that I specified all of the tables and the type, which is either a view or a table. So in that way I can access my metadata. Equally, I can, as I said, access the results metadata. So that is the database metadata, which I've been accessing, and I've been printing, as I show you, the table name and the type, which is defined as being either a table or a view, depending on the type that I get. Now, what I might want to do is, for a result set, access the metadata for that result set. So let's say that I have now a query that I execute associated with a particular connection, and I put the result set in RS. So that is my result set of the result of executing some query, str SQL query, whatever that query is. Now that result set has an associated set of metadata that I can access. So for that, I need to declare an object which is going to hold the metadata for the result set, and that's RSMD, which is of the type result set metadata. So I know this is going to have my associated metadata, and I created by calling on my result set the method getMetadata. So that actually creates the metadata associated with my result set. And then I might go through that metadata with a while loop. So I can say while I, which is a local variable, is less than or equal than. And for this, I'm going to use the method getColumnCount. So if I have 3 columns, I'm going to go for 3 different columns. If I have 4 columns, I will get the result metadata for the core columns and so on. So I'm already using the metadata there to know how many columns there are in my metadata. Then I'm going to print out the name of the column, which I do using the getColumn name, I, and then I am going to use a switch statement to print something if it's nullable or not. So I want to know for each column whether it's nullable or not. So if it's nullable for column I, then I either write nullable or I write non-nullable within that switch statement, or unknown if it is not known whether it's nullable or not nullable, or other if it doesn't follow any of these categories. Then I can carry on and also print the type of the column. I can print the type code, which might be something like integer, varchar, etc. And I can also print something like the display size, how many, what is the display size that is allocated to a particular column, and the precision and the scale with which a decimal, I might have a precision of 6 and a scale of 2 after the decimal point and so on. So if I do that in my program, and I run it, now I'm doing this, so let's see if I can put it. So what I'm doing here is I'm running this show metadata program, and I am going to execute a query which says select everything from the model M. So the metadata is going to be associated with that query. So my query returns all of the results from the employee table. So what I have in my metadata is all of the associated data which comes with that employee table. So I have executed that, and then I'm going to look at the metadata associated with that query. And that is going to allow me to understand what columns were returned, whether they were nullable or null, etc. So when I look at the results here of running the query, what I have is that I start with the first column, which is MPID. The label and the name are MPID. It's not a nullable column. The type is integer. The type code is 4 for integer. The display size is 11. The precision 10. The scale is 0. And then I go and it will print the next column, which is the name. The name has a label and a name. It's not nullable. It's of type varchar, which has a type code of 12. The display size is 20. The precision is 20. The scale is 0. And then I go to title and so on. So this returns all of the metadata associated with that particular query. If I change the query, then the metadata will change, because I will be looking at whatever comes associated with our result set. So it allows me to understand what things are being returned in my result set. So again, this is a program that you have and you'll be playing with in the labs to understand how to use it. So we just got a couple of things left to do. So we've looked at how you look at the table metadata and the result set metadata. Now the last type of things that we want to do is look at prepare statements and callable statements. Now, what we have looked at the moment is we execute a query. But if we want to change something in the query and execute it again, we don't want to necessarily be having to write the query again and again and again. What we want is a method of passing information to the query as parameters so that we can run the same query with different parameters. So we can do that with the prepare statements. So if we're going to execute the same query multiple times, what we can do is use a prepare statement, which may be more efficient for doing it. And we can create those using the connection object. The same as we create normal statements, we can create callable statements, and we can create prepared statements. Each parameter in the SQL is represented by an interrogation mark. And that is going to be replaced by a valid value when the query is executed. They also may be better at things like security, this type of prepare statement. So let's say that I have something like that. Select star from the model M, where MPID, and I want to do that for a number of different employees. So I don't want to have to rewrite the query where MPID is equal to 345, 456, all the time rewriting the query. What I want to do is write it as a prepare statement so I can pass the ID when I call the query, and it will be executed for different IDs. So that is going to be more efficient. So what I do then is I define this ID as a parameter with an interrogation mark. And that means that this is a parameter that the query is going to take. And I declare this to be of type prepared statement, because it's going to be one of these statements that has parameters that I can pass on when I execute it. And I declare that on the connection, as I did the normal statement, and I call the method prepare statement. And I pass it the string that I want to execute, which in this case is this string. So what happens is when I call it, let's say that I have an array of integers like I have here, with my first integer is 815, 848, 856. So I have three integers. I want to find, in this case, all of the details of these different employees. So instead of having to write the statement 3 times, I'm going to do a prepare statement. I'm going to set my result set, which initially is going to be a null value, and then I can say for int, which is a local variable I declare here, I equals 0, I less than the length of this array, which is going to be 3, I plus plus. Then I call this method setIn allows me to set the first parameter. So I said on my prepare statement that I declared earlier, I set the first parameter to be the value of the first numbers of this array. So that sets that parameter to take the value of 815, and then I execute with that. So that is going to have the effect of calling my SQL statement, but passing it 815 as the demo ID. I do it again because I'm going RS next. I handle the name, and then I go back through this again. So then I will re-execute this time for this number. And then I will print it out, execute again, this time for 856. So these prepared statements allow us to pass the parameters, or we can call this same query multiple times, but with different values each time. And then finally, we have callable statements, which are used to invoke store procedures. We talked about store procedures and store functions that might exist in SQL. And in particular, we looked at PostgreSQL and the store functions there. We might want to be able to call those from the Java environment, and we might have to pass parameters to that. To do this, we use this method called register out parameters to set the type of any return of the parameters in the procedures. And as we saw with the prepare statements before, the interrogation is a token that signals where you have your parameters. So in this case, we have a one-base indexing. So we have something like a procedure there, which is declared as one of my parameters is equal to get age by ID, and then to that I will pass another parameter. So that procedure is going to be called. It's going to have a return, which is at the moment defined by the interrogation mark, but it's also going to take a parameter which is at the moment defined by the interrogation mark. So this is my procedure that I want to call. And to handle that within Java, I have to declare something to be a callable statement, CS, and I can declare an object like that associated with my connection by calling the method prepare call, and I pass the string procedure. So this is me calling a function that I've written within PostgreSQL and being able to pass the parameters to it. And I can use this method called register out parameters to register the type of parameter. So I'm saying my first parameter is of type integer. So this allows me to specify that the first parameter, i.e. the return of the function, is going to be an integer. And then again I can have an array here which has values 1, 2, 3, and I have an age value which is initially set to 0, and then I go through a for loop for I equals 0, I less than the length of this array, so I'm going to do it for every element of this array, I plus plus. Now inside of here I'm going to set the second parameter to be the value of this array. So I'm saying my second parameter becomes first the value of 1. So then I call execute, and that is going to be a call the procedure that is stored in the database. So this execute is then going to call this procedure expecting an integer return, but passing into it the value of 1. So this is going to say get age by ID, get the age of whoever is my ID of 1. And I'm going to expect to return an integer, okay? So nh, which is my integer, then I get by doing cs.getInteger, and what I get there is the value of parameter 1. So that allows me to call the function, pass it a parameter that I've declared here, and then get my return into this nh. So this will give me the age of whatever person I'm accessing at the first instance with the value of ID 1. The second time I go through this is going to print it. The second time I go through this, then you're going to pass the ID of 2, so you'll get the age of the person with ID of 2. The third time, I'll get the age of the person with ID of 3. So I can use this to call store procedures by declaring something of type callable statement associated with my connection. Then I can declare the parameters, declare the input parameters, declare the returns, and call the function within my program and get a return. And that is the end of today.